you should have hopefully written down, how do I interpret the logistic growth model in context? And I can interpret the meaning of the logistic growth model in context. I'm going to give you a minute to go ahead and write that down. That virtual background is just weird. It's cutting off my face. Okay. We're under construction right now. Just a little bit. We're painting. You see the ceiling? Purple. Makes me happy. It's not like as neon-y as I had the boys' room painted before we had children, when I had a different room for crafts that I never get to do anymore. All right, but at least they'll all be organized. Okay, so we've got the logistic growth. In AB calculus, the exponential growth model is derived from the fact that the rate of change of a variable is directly proportional. Should we tell Habib the rumor? Okay, all right, to the value of y. When using the differential equation, dy dx equals ky, its general solution, y equals ce to the kx. You may have noticed the exponential growth is unlimited. So what they're talking about there is what we were doing the last few days is, hey, it keeps growing and growing and growing and growing, okay? And that's when we have this proportional relationship and this model, okay? However, when describing population, there often exists an upper limit. So when we have a population we are talking about, that's where we get this upper limit from, and which we can't, growth can't occur past that. So the upper limit L is called the carrying capacity. So you might want to underline that. It represents the maximum population that can be sustained as time increases. So the maximum population sustained with time. A model that depicts this type of growth is called the logistic differential equation. So this here is your logistic differential equation, okay? K and L are both positive constants, okay? L represents, so the L part of the equation is the carrying capacity, okay? K is kind of like a number just like it is in the other one. It kind of helps with, it kind of swings the growth a little bit. All right, so, but when we did, remember we did a little proof on how we got from the differential, this thing here, to this thing here. I decided on Friday we weren't going to try to prove how we get from this one to this one, okay? So that wasn't a good idea for a Friday, so I decided not to do it, okay? Because I planned that this lesson would be on a Friday, right, when I printed the notes. I didn't. I never do this proof. But anyways, so these two things you can kind of interchange, and you can interchange their parts, and you have to understand kind of which parts go where. So in this one here, notice that the carrying capacity is always on the bottom there, whereas on this one, the carrying capacity is the numerator. The K is always going to be in front of the Y. In this case, the K is going to be in the exponent, and it's typically a negative, okay? And then the Y, or what's this thing here in this differential always needs to be the number 1, or we need to get it to be the number 1, okay? All right. So we're going to look at this first multiple choice question. I'm looking for my cheat sheet. There we go. All right, so these, they kind of draw the line between multiple choice and free response. If it was on a free response, it would probably be like just part A or part B, or maybe actually or part C or D probably is more likely, because it's a BC level topic. But I see it, maybe not in your test, but in years to come, I see this going more free response just because of the nature of what we're living through right now, and it's very timely for that. I don't know that it will hit your test this year, but I'm sure it will be, logistics will be there somewhere in some capacity. It might not be free response. So the differential equation of a logistic growth is modeled, and they gave us this lovely model, has a solution, and they tell us, hey, here's the solution. This is what we get when we integrate that model. Find the solution to the logistic growth model for the differential equation. So they give us this differential. They give us an initial condition, okay? And we need to figure out which one of these equations it fits, okay? And notice, it sort of looks like this, but not quite, okay? So the first thing I am going to notice is this part right here. Do you see how it's not equal to 1? But I'm going to use my good math skills, and I'm going to get it equal to 1, okay? So how would I get this equal to 1? What could I do to the 10 to make it equal to 1? Tell me in the chat. Okay, we're going to divide by 10, right? Well, we really can't just divide by 10. We can't randomly do something to an equation. The only two things I'm allowed to do is add 0 and multiply by 1. So to get the effect of multiplying by 10, I'm going to rewrite this to the side here. Instead of doing that, or to get that effect, I am going to multiply by 10 over 10, which is like multiplying by 1. Okay? So in this case, I've got, ooh, that's not what I want. 10 times 2 would be 20y. And then I'm going to take the 1/10 that's left, and I'm going to distribute it through. Okay, so I get that dy dx equals 20y. 1/10 times 10 would be the 1 minus, and then negative y times 1/10 would be y over 10. All right, so we're going to try to use a little bit, since it's a multiple choice question, we're going to try to use a little bit of process of elimination. Okay, so looking at this at our logistic differential and looking at what we've got, what should my carrying capacity be right now? What's the L? Good job. Okay, so my carrying capacity, remember in this formula right here, is always the number underneath the y. So that's my L, okay? Notice, but then in the integrated version of the equation, okay, the L is supposed to be in the numerator. So do you see how A, B, C, and D all have a 10 in the numerator and this one does not? So that one gets eliminated based on that, okay? We can also look at the K value. The K value is supposed to be negative when we put it into the formula because the formula has a negative in there. So the sign has to be opposite. What's the K value supposed to be? Good job. I've got Gabby Lorenzo. Good job. It's supposed to be a 20. When I plug it in here, it should look like a negative 20. So it looks like I could get rid of C and we're down to B and D. So I have to figure this out based on the information I have. So is there anything left that we haven't used yet in there that we could help us to figure this out? What part have we not used in the stem of the question? Good job, Lorenzo. We have yet to use the fact that we have an initial condition, okay? So what I'm going to do is I'm going to plug into this formula here everything we know, including, or I'm going to plug in general, and then I'll plug in my initial condition. I'm going to do it over here so we can see it. So y equals, I already know my carrying capacity, you all told me was 10, okay? 1 minus, or plus, sorry, B, I don't know B. I don't know K, but I know that, actually I do know K. It's negative 20, right? Okay, so now I'm going to plug in my carrying capacity, or I'm going to plug in my initial condition. So 1 is going to be y. My goal is to try to solve for the b, because I need to know whether it's 9 or negative 9. So plus be to the negative 20 times 0. And we love it when that 0 ends up in that exponent, because that makes it e to the 0, which we know is 1. So it's really 1 equals 1 plus b. No, well, okay, so David, there's two things. You need to look at the formulas. In this formula here, yeah, the K is positive. When you go put it into this formula here, the K turns negative, okay? So it's part of the formula. What happened is we didn't see all the integration steps that took us from the differential back to the original. So that somewhere in those steps, that K turned negative, okay? Black and white, how did we do that? Okay. All right, so I'm going to get the b to the other side, or this denominator to the other side by multiplying. So when I multiply by 1, I get 1 plus b. So b, something went wrong. How did I turn my 1 into a 10, or my 10 into a 1? I don't know. So b is equal to positive 9. Okay. So if I plugged back into this one right here, I'd get y equals 10 over 1 plus 9e to the negative 20t. So it is, in fact, answer choice B. All right, how are we doing? We doing okay? We had to plug our b back in. And we always go into the step right before we plugged in our initial condition. All right, we doing okay? All right, let's see if we can go a little bit further. Oh, I'll wait. I'll wait. One plus b equals 10, yes. Why 10? Because our 10 was our carrying capacity, so that ended up in my numerator. Originally, I miswrote it as a 1 for a while. It was part of the formula, and I was just manipulating the formula. Oh, and maybe because I had to multiply this to the other side, right? So I switched my division to multiplication, and I distributed the 1 through. 1 times 1b, 1 plus b is 1 plus b. Okay? All right, I'm glad I finally figured out what you were talking about. You're welcome. All right, let's keep going. Because some of this is incredibly easy, okay? This is actually probably better than all of 7.8, okay? So the number of photoplankton specimens in a laboratory tank at time t is increasing according to the logistic growth model. Which of the following statements could be true? Okay, so let's go through all of the statements and try to decide what's true and what's false. So if I look at this first one, one of the things, it's almost set up in this equation here, right? It's almost kind of looks like this one. The catch is, look at the exponent. What's wrong with this exponent right here? What would we want to see on that exponent? Yeah, it needs to be negative. So this one would be out because the exponent's not negative. And if it was me taking notes on this, I would want to write that reason down, right? Because you wouldn't necessarily write it on a test, but you need to, when you go back and try to process this or try to do problems that I assign, you're going to want to know that that's negative, okay? Or that was a negative. All right, looking at B. So B is a little bit different. It's not logistic growth. So what this one looks like is it looks like a K times a Y, which is directly proportional. And I know a few of you guys came this morning, but I was actually doing homework with Ellie the other day, and she had these graphs that she was working with, and they look something like this, and she had to decide which ones were proportional and which ones weren't. Okay, so when we talk about something that's directly proportional, that means it should have a consistent slope. Okay, do you see how that K in front makes a consistent slope? So these would be pictures of things that are directly proportional, whereas this is definitely going off exponentially. Okay, so this one here, because of the direct proportion, that one is not logistic. Okay. And I thought it was a really interesting, it was a good connection that I finally, put back together. Oh yeah, that's what that means. Okay, because we don't teach inverse and direct variation very well anymore like we used to when I was going through school. All right, and it's usually in like 7th grade and we all forget about it. So the next one, so here, let's see how we can dig deep into our AB calculus. That means second derivative positive, right? Correct, Gabby, logistic is never directly proportional. So second derivative positive. What does the second derivative represent? I'm going to give a little hint. I know. Oh, there we go. You didn't even need the hint. I'm telling you, you need to think about math. All right, because it's clicking. All right, so it represents concavity, right? So this here means if it's positive, that means it is always concave up like a cup, right? So, but remember our logistic curve? If it tells us in here that it's following the logistic growth model, it's concave up and then it switches to concave down. So if it's always concave up, I can't use that. So by default, process of elimination, it would have to be D, but let's examine D just a little bit closer to make sure we've got it, okay? So let's look at what it would look like. They've already done separation of variables, so I'm going to unseparate the variables and put them back, okay, the way we would see it ahead of time, because that's what it would look like in this formula here is unseparated. Okay, so let's see if we can get back to something that looks a little bit more like that. So I would take the dt and put it back over here underneath the dp. And then I would take this thing here and I would multiply it over to the other side. So I'd have 0.035p times 1780 minus p. And then we know we could do our, divide by 1780 thing, right? And get a 1 there. So we know we could do some arithmetic to be able to get this to a 1. But do you see how it's starting to look much more like this formula here? Okay. So that way I know that that's definitely representing the logistic growth model. Okay, so that's your correct answer would be D. Okay. On the next one, actually the next two, it's going to take me longer to explain them than it is to actually do the arithmetic on it. Okay, so you're going to like these problems. You're going to want like 10 of them on the next test. I'll put 1. Okay, so the spread of an infectious disease to workers on a large floor of an office building is modeled by the logistic equation. Okay, where T is the number of days and P of T represents the number of infected people. The graph of P of T is shown below. What is the number of infected people when the rate at which the disease is spreading is the greatest? So just looking at the graph there, when would if thinking about how we talk about graphs, okay, when would it be growing the greatest? Gabby, I'm telling you, you've got it. So since when does the UPS driver not drive a UPS truck anymore? They must be hiring extra people. Because I'm watching this random car out there and he puts on his UPS jacket, but it's like a little red car. Okay. All right, so I've seen some things after I got distracted. So when my slope is the biggest, right? So somewhere in here, when my slope is the steepest is when it's going to be growing the fastest, okay? Or it's going to be kind of maxing out the growth. So if you'll notice, that slope is the steepest right in there. What do you notice about this number compared to maybe our equation? Is there some information in our equation and that number that kind of maybe have a relationship? Any guesses? Good job. It's half of 800. What is the 800? What do we call that? That is our carrying capacity. So all we do to figure out where the steepest growth is, okay, is we take our carrying capacity and we divide it by 2, and that will get us the answer. It's like the best question ever, right? Look at all of that with all those words, and all you literally have to do is divide by 2. Okay? All right, so let's take a look at example 4. It's similar, okay, except that you notice how this one started with the original growth function, original logistic growth function, versus this one is the differential. Okay, so it's the same question, but like the model looks a little different. Okay, So the rate at which natural gas is being extracted from an underground reserve at time t satisfies the differential equation dg over dt equals 0.4 g times 1 minus g over 64, where g is measured in thousands of cubic feet and t is measured in weeks. For what value of g is the extraction rate increasing the fastest? It took me longer to read it than it probably took you to do it. Did you all finish it already? What's the answer? All right, so all you had to do was find the carrying capacity, which was sitting right here, right? And divide by 2, right? Because the increasing the fastest at half the carrying capacity. And so if y, it's 32, not 2. So it should be 32. It is B. Okay? Gabby, I hope you really knew that and you're just saying that you didn't. All right. Let's take a look at example 5. So here is what, if we were going to just step out an entire logistic equation into a free response, this is what we would see. Okay. Likely it would probably be one of these pieces, not the whole thing. We're going to see what we can get done in 8 minutes. It really, the part B or part C is probably the longest, and I might not do all of part D and E. I might just set them up for you. Okay. All right. So a conservation organization releases 30 panthers into a preserve. Okay, so what is that? What is the 30 panthers? If we're releasing them into the preserve, what do we call that? There we go. Good. Initial condition. So my initial condition is actually 030. Doesn't hurt to write that down somewhere. After 3 years, there are 50 panthers. So there's another data point, right? 350. The preserve has a carrying capacity of 150. So that's got to be my L, right? 150. The growth rate of the panther population is given this, which means we're in a logistic growth model, which has a solution this. So those are our 2 indicators. Hey, we're using logistic growth. Okay. We have to find L. Okay. Didn't we already do that? Wasn't it 150? Right? All right, now we have to find B. So what I'm going to do is I'm going to go into this. I'm going to use that equation right there. And I am going to try to use my initial condition in order to find B. So I'm going to write out my, it's A, not A, P equals the carrying capacity 150 over 1 plus BE to the negative KT. So I'm putting the 30 in for the P, 150 over 1 plus BE to the negative K times 0. So 30 equals 150 over 1 plus B, because K times 0 is 0, and then E to the 0 power is 1. How am I going to get this 1 plus B to the other side? What do I need to do? We need to multiply. Good. Yes, if they want you to solve for this, they're going to have to give you carrying capacity in some way, shape, or form, Gabby. Okay. All right, so we've got 30, and I'm not going to distribute right away. Okay. So it was kind of about a month ago, my husband and I were talking about something my daughter was doing in math, and I said, oh yeah, she'll just automatically distribute. Okay. How come I got 0? You mean up here? I got 0 because they told us in the beginning our initial condition is 30 and our time always starts at 0. Okay. All right. So what I was going into is my husband's like, oh, shouldn't you just divide? So a lot of you guys might distribute this in, but it might actually be easier or arithmetic wise to actually just divide that over right now. So you get 1 plus B equals 5. Rather than distribute through and then subtract and then add, that would probably be a better strategy arithmetic-wise. So B is equal to 4. All right. I'm going to go through the exact value of K, and then I think D and E you'll be able to do on your own. Okay, and then we'll quickly talk about F. Okay. All right, so we're supposed to find the exact value of K. So I know right now that P equals 150 over 1 plus 4, because I calculated that in the last part, e to the negative KT. We have more information that we haven't used yet, right? We have this information right here where we saw that 3 years there were 50 Panthers. So I'm going to use that and plug that in and then try to solve for K. So I know that it is 50 Panthers total equals the 150 over 1 plus 4e to the negative K times the time, which was 3. All right, I'm going to multiply this mess over to the other side. So 50 times 1 plus 4e to the negative 3k equals 150. I'm going to use my same trick where I divide the 50 to the other side. So 1 plus 4e to the negative 3k equals 3. I'm going to subtract the 1 over. So I've got 4e to the negative 3k equals 2. So e to the negative 3k equals 1/2. I should have left myself a little bit more space. What am I going to do now to get rid of the e? Gabby, you had it up there before I even... Okay. All right, you're way too far ahead of me. All right, so these guys are going to cancel. I now have negative 3k equals the natural log of 1/2. I'm going to divide by negative 3, or I'm going to multiply by negative 1/3. So negative 1/3 natural log of 1/2. All right, our model, all you have to do now is plug that K in. Okay, so it's going to be 150 over, I guess I am going to do this part, 1 plus 4e. Now, we ended up with a negative here, so it's going to be a negative 1/3 natural log of 1/2 times t. So that's our model. To get the population after 12, you're just going to plug 12 into the model. Okay, so let's talk about F really quick, because I know that the bell's going to ring in like a minute or less. If I'm going to talk about the limit of this model as t approaches infinity, I don't know what it was called, p, right? What is the biggest this is ever going to get? So as I go out to infinity, how high can it get? It can't get any bigger than 150, right? So whenever you see the limit, like you want this question on the test, right? Because it's got to be the carrying capacity, right? So the limit of our rumor in class, our simulated rumor, would be 26, right? So we couldn't get more than 26 because we doubled everybody in the class. All right? Okay, that's all I have. You're welcome to leave. But if you don't want to leave yet and you want to hear the joke, I can do the joke. Do we need the joke? Okay, so I will do the joke. If you need to go, you may go and eat your lunch. Okay. Is the answer 120 for E? I don't know. I didn't calculate it, Gabby. I'm sorry. I don't happen to have the answer for it. Okay. All right. I'm going to hit the stop record button and then I will do the joke. Okay. Stop recording. As a reminder,